Today we're going to see an example of an electrical system and how we obtain the equations in the individual equations from the system. We're going to see the Cauchy form of the equations. We're going to see the state space form of the equations. And ultimately, we also will do a little exercise on how those going to Simulink. But in any case, in here, you consider this electrical circuit as you see in there. The first thing that we got to do is to complete the bond graph model of this. This would serve us as a good exercise on the process that we use for generating bond graph models for any system. The first thing in an electrical system is we put a one junction for every distinct current that we see, I1 and I sub 2 over here. On step 2, we attach the elements that experience those currents. And of course, I think in this case, let's just change the color for now. This is going to be in here the R with value R sub 1. Yeah. This would be the source of effort here, which is with value source of effort with value the input voltage. Then we have over here a inductor that is the with value L1, and we have this element in here which is C with value C sub 2, and in between these two we have to create a difference between the currents. So we do that. That's step number 4 of our procedure. We create that down here. This would be I1 minus I sub 2, and that is what these two elements experience. So that is the C element over here as well as the R element. So with this would be with value C sub 1 and this with value R sub 2. And I believe we have finished the bond graph model here. I think what we need to do is to finish the causal marks on the numbers, but I think as far as the simulation is concerned in CampG, you could put this in there like this, and the program will assign you the numbers and the causal marks as well. So, but since we're doing it by hand, we need to put that in here. Let's see, 7, 8, and 9. Yeah. Once we have this and the causal marks, we need to complete this one is like this, makes this with this flow in here into the one junction, makes the other ones like this. Now we have some other, let's see, we can put this in integral form right there. So it looks like we have like an algebraic loop or things like that on here, something that I did not realize when we set the problem. Yeah, we do have an algebraic loop here. See, the causality does not complete, but I believe that we could fix this very easily. And since our objective really is to derive the equations and not deal with the algebraic loop, I would propose that we add in here an inductor element in here, and this we're gonna call it L sub 2 in here, just for the sake of example, because what that would do is will give us another I over here with this L sub 2. And when you put that in integral form, then this becomes like this, And when that happens, this one is forced to be the effort input in here and completes the causal marks perfectly here. So with that small modification, we have a system that doesn't have any troubles really, and also an integral form, because our intent right now is to deal with the derivation of the equation. So I have written a set of steps up here that can be used. The first thing is we write the E's and the F's in each bond, considering the power flow and the causal marks. To consider which bonds set or cause the efforts on a zero junction, consider how the flows will act, or consider which bond set or cause the flows in a one junction, consider how the efforts act. Then derive the Cauchy form, and then we have to do that, we need to start with the derivatives we find. So let's do it fairly quickly so that we don't draw attention too much to the just the individual equations by hand, but rather we concentrate as a whole into the derivation of the state space form, which is more important. So this is SE1 like this for E1, and F1 is equal to what? To this one we need to have a number in here. This is a 10. So this is F sub 10 because it caused 10. E sub 2 is what? E sub 2 is F sub 2 times R sub 2. Yeah. And then F sub 2 is F sub 10. And then I am going to go to E sub 3. Who caused E sub 3? Is E sub 5. And then F sub 3, how is the F sub 3 originated? F sub 3 comes from this, from F1 minus F2 minus F10. That's what F3 is. This is F1 minus F sub 2 minus F10. And then we have, E sub 4. This is E sub 5. And F sub 4 is equal to F sub 8. E sub 5 is equal to what? To E6 plus E sub 7. And then F sub 5 is equal to what? The F5 is F3 minus F sub 4. Yeah. And then we're going to get to E sub 6. Well, let's just maybe draw a line over here. And we'll continue up here. This would be E sub 6 is equal to what? 1 over C sub 6 times Q sub 6. F sub 6 is equal to F sub 5. And dQ sub 6 dt is equal to F sub 6. That's from this C. So now the 7, E7 is equal to what? To F sub 7 times R sub 7. And then F7 is F sub 5. Then E sub 8 is equal to, right here, E8 is E4 minus E9. And F sub 8 is equal to 1 over I sub 8 p sub 8 and dp sub 8 dt is equal to e sub 8. We're almost done. So we go to 9 would be e sub 9 is 1 over c sub 9 q sub 9. F sub 9 is f sub 8 and dp sub 9 dt. No, 9 is dq sub 9 dt. So let's just have this correctly here. And so this we are on this one. This is dq sub 9 dt is equal to q sub 9 dt is equal to f sub 9. So e sub 10 is equal to what? E10 is E1 minus E2 minus E3. And F sub 10 is 1 over I sub 10 P sub 10. Yeah. And then this the P sub 10 dt is equal to E sub 10. So those are all the individual equations that we would ever need. We have considered which one caused the efforts on the zero junctions, because in this zero junction, for example, F sub 5, E sub 5 is the one, and in here, so E4 has to be E5 and E3 has to be E5 also. In this one, the flow was caused by F5, so F sub 6 and F sub 7 are equal to F sub 5, but in this case, yeah, F7 and F6 equal to F5, the one that caused it. Same thing over here, you know, F sub 4 and F sub 7, F sub 9 are F equals to F sub 8. So you see F sub 4, F sub 8, see, and then you have F sub 9, also F sub 8. So we are correct on doing this. I think now we are turning our attention to the Cauchy form of the equations, because now with what we have done, we can recognize that we have one equation here, equation number 2 over here, then 3, and then equation 4. So in this case, we are going to write the equations, the Cauchy form of the equation. So we start with the derivative. What is dq sub 6 dt? This is equal to f sub 6, and then we just substitute what we have written here. This is f sub 5, and what's f5? f3 minus f sub 4. And what's f3? Is this one, f sub 3? No, f sub 3 is f10. F sub 3 is f sub 3. This one is caused by f10. So we have a slight error in there, something that does not happen with a computer program. This is for this one, not the one, but just F10. That's all. Yeah. So F sub 3 is F sub 10 minus F sub 4 is what? F sub 4 is F sub 8. And so F10 is what? This here, 1 over, see right there, minus, okay, what's F sub 8? Is 1 over I sub 8, P sub 8. This is the first equation. So I am gonna write it down with red ink so that all of them would have good exposure. It's 1 over I10, P sub 10, 1 P sub 8. That is the first equation. There are 4, remember. We need to go over here, dP sub A dt. So dP sub A dt is equal to E sub 8. But E sub 8 is E sub 4 minus E9. And then you have E sub 4 is E sub 5. And E5 is E6 plus E7. Minus E9. E sub E4 is E5. Yeah. And then this E9 is 1 over C times Q sub 9, right? No. What is E9? It's 1 over C times Q. See right here. 1 over C9 C sub 4. So that's E sub 1 over C sub 4 Q sub 4. And here you have E sub 6 is 1 over C sub 6 Q sub 6 plus E7. So that is F7 times R7 minus 1 over C sub 9, I believe it is. Or is it? Yeah, no. This is not a 4, it's a 9. It's 1 over C sub 9 Q sub 9. Yeah. So this is the other equation that we have. The equation that we have now, you know, this F7 is still missing, is dP sub A dt is equal to 1 over C6 Q sub 6 plus, what's F7? F7 is F5, but F5 is F3 minus F4. You could calculate separate here F sub 7 because it's to our advantage to do that. Is F sub 5, and F sub 5 is F3 minus F4, and F3 is F10, minus F4, which is F8, and F8 is 1 over I sub 8 times P sub 8. Am I right? See, this is F10, and what is F sub 4 is F8, 1 over I sub 8 times P sub 8. So, we have F7 would be, but then I didn't complete this. This right here is 1 over I sub 10 P sub 10 minus 1 over I sub 8 P sub 8. Then we're fine. So that we need to replace here where it's necessary. 1 over I10 P sub 10 1 over P sub 10 minus 1 over I sub 8 P sub 8. That is just F7. Terms are 7. And then minus, this was possibly the longest equation. And this is the second equation. And then you need to have a third, which is this one right here. And so this, we're gonna go over here and say dq 9 dt. See dq sub 9 dt is equal to f sub 9. And then you have f sub 9 is f sub 8. And f sub 8 is 1 over m sub 2 times, not m. Let's use the word I, so that it's all generalized. F sub 8 is 1 over I F9 is F8, but F8 is 1 over 8 P sub 8. And so that is the third equation. And the last equation, just as we do, is dp10 dt. So I am going to write this down. This would be dp10 dt like this is equal to E10. So E10 is, what is E10? Yeah, here E1 minus E2 minus E3. Yeah, so that's E10. Then we need to transform it. What is this? Is SE1 right away. And then the 7 would be what? Okay, E sub 10. So we need to substitute this other one. 7 and 3. E sub 7 is F7 times R7, and E sub 3 is, the Q7 is F8. So F7, where's this E10? E sub 3. E sub 3 is that E sub 3. That's this one over here. E sub 3 would be E1 minus E2 minus E10. Yeah, okay, let's see, what did I say? So E sub 3 is E1 minus R2 minus R10. So I think we need to find out what F7 was. See here that this was, so you could go one more step and rewrite the whole thing, and that is that dp10 dt is equal to E sub 10. Yeah. Okay, so we have E sub 10. What is E10? E10 is all this, right? So on F7, you already figured it out what it was, or not. Yeah, see here? This is what you have. So you have all the tools here. So this is E10, and then what was in here, plus 1 over I sub 10 P sub 10. All right. E1 minus E2 minus E3, this says here. So, well, E1 minus E2 minus E sub 3 plus 1 over I sub 10 P sub 10. I think we have a mistake in here that I wish to correct. This is already E1 minus E2 minus E3. We cannot be doing that again. So let me just go back. I think there was a little mess up in here. We already have this. This is SE1 in here. That's the idea. This is SE1 minus F7. Yeah, we already calculated over here. So this would be 1 over I10 P sub 10, and then you have minus I sub 8 P sub 8. And those are the 4 equations. So now all we gotta do is to put them in state space form.